a law. So a law in science, do you know how you become a law in science? So in science, to become a law, you have to do an experiment and get this result. But then, if other scientists can do the exact same experiment as you and get the same exact results, eventually that becomes a law. Now in math, this is the equivalent of a law. So it's something that mathematicians over and over have found has to be true. It's always true. And this law says that if you have an imaginary root of a polynomial, so they call it a plus bi, that's how it wants to come out. So that's like something like 2 plus 3i, it's a number. If that is one of your roots, then automatically its conjugate, we've talked about conjugate, a minus bi is automatically also a root of your polynomial. So you get one imaginary root. If you have it, you get the other one for free. That's what this theorem says. So we learned not too long ago, we remember that square root of -1 is I. So what did we say in the last unit I squared was? -1. Because remember, if I square root, or if I square the square root of -1, the square root goes away, and you're left with -1. That's going to be a really important number to note here today. So let's build the equations of polynomials when we have imaginary roots. But first, let's make sure we understand what this conjugate pairs theorem is telling us. So for example, it says, if I have a polynomial that has 4th degree, and I know that it has the roots positive 4i, 3, and -8. I'm missing one of the roots. Right, so the conjugate pairs theorem tells me that if I have this positive 4i as a root, what other root do I automatically get? -4i. Right, so that's your missing root. The conjugate pairs theorem says if I have one I get its conjugate. So therefore, this makes sense. If I have degree 4, how many total roots will there be? 4. 1, 2, 3, 4. So I know now that I have all 4 of them. If I have degree 3, that means I need 3 roots. Well, here I have I radical 11. That's one root. 6 is the second root. What's the third root? -I radical 11. Okay, just making sure you understand how the theorem works. Then if I have a degree 4 polynomial, I know one root is 5 plus I. So what other root do I get for free? 5 minus I. And if I have -I radical 3, I also get positive I radical 3. Okay, see how the theorem works? So let's actually write equations. This is similar but a different process than what you just did on your quiz. So for example, say that you have a polynomial and you know that it has a root at 5 and a root at 2i. What root is missing did I not write down? -2i. Okay, it's conjugate. Now, total, how many roots does this polynomial have? 3. So when we're done, we expect this to have a degree of 3. All right, so here's how we're going to do it. It's going to be a little bit different than the last lesson. Just because I use this different strategy because I think it just makes it easier with the eyes. First of all, I would write it this way. You know you have a root at x equals 5. And you know you have a root x equals, I'm going to combine them into positive and negative plus or minus 2i. All right, that's what we have, positive 2i and negative 2i. Now, the reason I wrote them like that is because we need to figure out what factor gave us 5 and what factor gives us 2i and negative 2i. So here's what we do. Technically, you guys know this already, but what factor in parentheses would you write for x equals 5? X minus 5. You did that on your quiz today. Now let me make sure you understand how we got there. Technically, what you did is you subtracted 5 from both sides, and you got x minus 5 equals 0. That's how you got that factor. So over here, I need to get this little mini equation set equal to 0 so that that's considered the factor. Well, first of all, have we ever had a factor, a set of parentheses that had an I in it? No, so I don't want the I there. So we need to go back and use this idea of knowing what I squared is in order to get rid of the I. So what we're going to do in this problem is we're going to start by squaring both sides. And here's why I'm allowed to do this. I know there's a plus or minus there. What's positive 2 squared? 4. What's negative 2 squared? 4. So So it doesn't matter if I have a positive or a negative. I'm going to get 4 either way. So that's why I'm allowed to just square with the plus or minus there. So if x squared equals, we already decided that was 4, and what's I squared? Negative 1. Well, what that gives me is x squared equals negative 4, and to get the factor, I just add 4 to both sides. So you get x squared plus 4 equals 0. And that's the other factor that gave you those roots. So we're not actually done. We're partway there. But I now have to take both of those factors that I found and multiply them together. That's going to give me the standard form. So I'm going to take x minus 5 times x squared plus 4. That's actually the equation in factored form here. But we want standard form. So if you don't like multiplying this, it's not the unit for you. Right? X times x is x cubed plus 4x minus 5x squared and minus 20. Now all I have to do to put that in standard form technically now is swap positions of those two, so we're in descending exponent order. Right, so your x standard form is going to be x cubed minus 5x squared plus 4x. Follow that okay? Yeah. A little bit. We'll do a couple more. What's the degree of that polynomial? No? Highest exponent. Oh. 3. And that's good, right? Because how many roots did we have? We had 3 total roots. What's the maximum number of turning points here? 2. Now, how many real roots does this polynomial have? 1. 5 is the only real root. 2i and negative 2i are imaginary. So it has 3 total roots, 1 real root. And what would be the end behavior? I have an odd degree, positive leading coefficient. So that means my left side starts at negative infinity and ends at positive. Now I've only seen one of them, so it's a little bit weird. It's still kind of like, okay, I followed the algebra, but I'm not confident. So let's try the next one over, number 5. I have a root at 6 plus 3i. Right, that is one number. What is its conjugate that I'm missing? 6 minus 3i. Right, I need the 6. So when I set this up, I start the same way. I set it equal to x. I'll say I know I have a root at 6 plus or minus 3i. And I'm going to go through a really similar process, except I can't square things yet. I need to move the number that's in front of the plus or minus before I square. So I'm going to subtract 6 from both sides. And I'll get x minus 6 equals plus or minus 3i. Now, how do I get rid of the plus or minus? How do I get rid of the I? By squaring. When I square the left, do not fall into that Algebra 1 mistake of not writing this out, of just writing x squared minus 36. That's not right. It's x squared, x minus 6, x minus 6. When I square the right-hand side, 3 squared is 9. I squared is negative 1. So what is this number here? Negative 9. When it's an I, it'll always be negative. So all we have to do is FOIL and combine like terms. So when you FOIL all that out, you get x squared minus 12x plus 36 equals negative 9. And the last thing you have to do is what? Add 9. So my standard form is x squared minus 12x plus 45. Is there anything else to multiply by? No, right? So that's it. That's your standard form. That's the equation. What's the degree of that polynomial? 2. And why is that good? How many roots do you have? 1, 2. Right? You had 2, so that has degree 2. What's the maximum number of turning points? 1. How many real roots are there here? 0. So does this graph ever cross the x-axis? No. And then if I have degree 2, positive leading coefficient, where do both arrows go? infinity. All right, we're going to do one more together. So flip your paper. Give you a second to copy if you need. We're going to do number 7. Number 7 looks a little bit different.
Oh no.
Oh no, it's okay. It's okay. So we're at 2, radical 3, negative radical 3. What am I missing? Do I have an I listed up there though? No, I'm not just going to throw I in. Actually, I have no missing roots this time. There are none. Right? The conjugate pairs theorem only works for roots that have an I. So if I have 3 real roots right there, I'm not missing any of them. I already told you that they were all there. So we actually, even with the square roots, we're going to start out the same way. X equals 2. And then over here, I can combine those radicals to be x equals plus or minus the square root of 3. All right, so if I subtracted 2 here, what factor do I end up getting for x equals 2? X minus 2. All right, so that's technically the factor we're going to use in a minute. Over here with x equals plus or minus radical 3, what do you think I need to do to get rid of the square root? Square both sides, just like with the I. So we've got x squared equals 3. And all we have to do is subtract the 3 from both sides. And this factor is x squared minus 3. Now again, I'm not done, but at least I can take these factors here, and I'll just multiply them together. I just distribute. X times x squared is x cubed minus 3x minus 6x squared. No, that's not right. Minus 2x squared. Plus 6. I know. I'm off my game. I know. Had 2 days off. What is this? Alright, so my standard form, I just flip-flop these numbers. X cubed minus 2x squared. Alright, what's the degree of this polynomial? 3. How many turning points can it have maximum? How many real roots are there? 3 real roots. Do I have any imaginary roots this time? No, they were all real. And then the end behavior would be the same as the first one. So I have odd degree. So I'm going to start low at negative infinity and end at positive. Okay? Do you follow along okay? So in the last couple minutes, I'm not going to give you a lot of I'm not going to give you formal homework over the long weekend. I would like you to try the last problem. There's the answer, even if you just want to write it down so you can check. There's your answer. And then, secondly, I did give you the test review. Maybe at some point before class Monday, take a look and start working on that a little bit, just because remember our time's going to be limited last week, and since the sub didn't give it to you, little hard. All right, but otherwise, I'm going to come around for a minute, say.